Okay, now the beauty of experiment number 6 is that you can essentially use the identical setup that you had in the second half of experiment 5. Okay, so as it's taking you through the setup, it says find a smooth horizontal surface at least 80 centimeters high and 80 centimeters long. It is best to use the same surface you did in experiment 5, the nature of rolling friction, as the values of rolling friction will be the same or very close. And then 2, using the pulley from experiment 5, take the pulley to the end of the surface, and we did that. Then it says take 3 pieces of printer paper and attach them to the end to end as you did in experiment 5, and we did. Number 4 says tape the 3-piece sheet from step 3 to the surface from step 1, so that the end of the sheet is within 5 centimeters of the pulley. And now, right now, I've got my pulley taped to the paper from experiment 5, and so I'm going to remove this. I'm going to move my sheets of paper back a little bit. That's good. It said within 5 centimeters. And I'm going to retape this here. So that way look closer to what's required. There we are. Okay. And now it says mark a line labeled stop near the end of the sheet close to the pulley. And so you'd mark a line, and I have other lines here as well, but I'm going to grab my tape and my pencil. Apparently my pencil was eaten. Oh, there it is. Haha! So I'm going to take my tape and my pencil, lay this back down. Again, I'm going to start at the 2 because that way I'm not having to deal with the end issues. And it says starting, let's see here, where are we? Mark a line label stop near the end of the sheet close to the pulley. And so I'm gonna take it, I'm gonna mark it at like 5 centimeters. And this is stop. And now I'm going to take that back and I'm going to start there. Okay, it says use a measuring tape to measure 10 centimeters from the stop line in step 5 back toward the end of the sheet opposite the pulley. Mark this line and label as 10 centimeters. And then in the very next thing it says repeat step 6 for 20, 30, 40, 50, and 60. Do not keep measuring from 10 centimeters, but just keep running along the tape. So we start at the stop line here, and at every 10 centimeters we're going to make a line. So there's 30, there's 40, there's 50, and there's 60. And you would want to label these each time. Record the distances with uncertainty from steps 6 and 7 in Table 1 measurements for the work energy theorem and conservation of energy as D10 plus or minus delta D10, and you do D20, D30, that sort of thing. Use the 500 gram digital scale to measure the mass of 15 like paper clips. Okay, so I have got a pile of paper clips. I suggest using smaller ones because they're a little less weight, but you're going to take 15 like paper clips. And so here's 15 like paper clips, and you're going to measure these on your digital scale and record that value. All right, and then it says record this with uncertainty and data table, or divide each of M sub 15 and delta M sub 15 by 3. What this does is this effectively breaks it up into groups of 5. It says record this with uncertainty in data table 1. Multiply that by 2 and record that with uncertainty in data table 1, so you have 3 pairs of measurements, 5, 10, and 15. Now find a piece of string 70 again. You can totally reuse experiment number 5 if you so choose. Measure the mass of the car with tape just as you did in experiment 5 and record that in table 1. Record the value of the coefficient of rolling friction for the car whose mass we measured in step 10. Now this is from experiment 5 directly, and so you should have calculated the coefficient of friction for this car. That's what you need to have. Make sure that you're recording the correct coefficient of friction because both cars will have a different one. And then you just proceed with the experiment. And that's the setup for experiment number 6.